Hello everyone, hello professor. This is Mohammed Taslim. So I'm going to explain on Project 1, which I've done as part of Web Analytics Week 5. So basically I took the data from airport databases, so which has some details on flight details, routes, countries, etc. So the intention is to represent the airport and the flight routes through the graph network and do some analysis on the variables present in the data. Let's see how it goes. And from the data perspective, I took the data from the openflights.org. It's a open source website. We have data like airports, airlines, and then routes, etc., planes, something like that. So for this project, I took only two data sets, which is the airport data set has what are the airports we have across the country, and what is the latitude and longitude, and what is the airport code associated with that. So those kind of details will be present in the airport data. And then the route data. So the route will have information about what is the source airport, what is the destination airport, from where to where it went on. So those two data sets are imported for this analysis. So, and then coming to the libraries, I use different libraries, pandas, numpy, netokx, matplotlib, skype, etc. So first I'm reading the data on the airport data. It looked like this, and then route data, doing some cleanup on the route data. I'm changing some variables from string to integer just to get the do some analysis later on. And then I'm merging those two data sets based on some airport code. So for this analysis, I'm picking only the United States data and variables like name of the airport, what is the latitude, longitude, the IATA code. So IATA code is nothing but the International Air Transportation Association code, which has some 3-letter keywords to identify which airport. And then I'm picking about the source and destination airport, and what is the time zone associated with that. Even in US we have around 6 time zones: Eastern, Central, Mountain, Pacific, Alaska, and Hawaii. So I'm just converting, since we have in the numerical data format, so I'm converting into the string just to have some better understanding about the data. So if you look here, so this is the final data it looks like. So we have the IATA code, so how many flights we have in each airport, what is the latitude, longitude, and what is the time zone associated with that. So let's do some quick stats about the data, airport data. So we have around, even in US, we have around 5,450 number of records. It has some stats about what is the mean, standard deviation, minimum value, max value, etc. And then coming to the graph creation, so I just picked the 200 samples of record because too much of data around more than 5,000 nodes will create just a clumsy network diagram. So I just picked 200 for better visibility. So here is a graph look like. Yeah, it has so many of connections from source to target, where the flight's going and coming, so on. So after that, I'm going to find the degree, the centrality measures, degree and the eigencentrality. So basically degree centrality is something, it's a simple score based on number of links on each node. For example, if a node have one edge, the degree of centrality would be 1. The higher value indicates the node is more central. So in case of eigencentrality, something has more information. It influenced by multiple factors. So how the nodes are well connected between each node. So that's about the eigencentrality. So this is a comparison between the eigencentrality and the degree centrality. These are the airport codes and comparison table over here. So let's take an example of this airport, something like UST. So it has a degree centrality of very less than 0.003 and the eigencentrality of 8.0, which may tells us like this must be some regional airport which has very less number of flights. That's how it's very well connected, but the number of flights is very less. It's showing the degree of centrality is very low. We can take it in that sense. So coming back to the categorical variables, so I categorize those data based on time zone, 6 time zones. So here is the data will look like. So from source like Chicago Airport and ATL Atlanta Airport, and which comes to the central zone since the source is originated from the Chicago, and similarly there we have other data as well. So ordered by the number of flights flowing between two places basically. So if you see here, from based on the data we have, the source of Chicago to Atlanta we have around 20 flights on daily, and then similarly Atlanta to Chicago we have 19, something like that. So let's do a quick test on the how we can do some t-test on that. So basically t-test is nothing but the comparing the two averages, and it tells you how they are different from each other, and we arrive some scores which called t-scores. It's a ratio between two groups and what is the difference between those group. The larger t-score will tells like the groups are very different, the smaller will tells me the groups are very similar. So the first I took the top two regions, central and eastern, based on the number of flights each airports hold. Let's do the t-test. I have the p-value of 7.6, something like that. So the p-value is so much of higher, so which means the very weak evidence against the null hypothesis. On the other hand, when you do the t-test on the counts, so number of flights flowing through between airports, arrive the p-value of 0.008, which is actually good. So it says that there are good number of flights between central and eastern region compared to number of flights between central and eastern region. So that was the test which implies us. And finally I did some plotting on the map using the base map library. I took some data, latitude, longitude, everything. Yeah, here you go. So this is the flight routes in USA. So if you look at the graph over here, based on the data we have, I took the bigger routes, higher number of routes I indicated as in the red circle, which has more than 100 routes, and then the small blue circles which have very less number of routes, and the green color represents how it got connected. So that's all about this project. Thank you so much.